Okay, continuing on with our nice little journey of slope here, let's start talking about something called parallel and perpendicular lines. In this case, I'm going to just scrap the perpendicular lines. I'll get back to it in the next podcast. But I'm going to really concentrate on something called parallel lines. And if you read this, this says lines in the same plane that do not intersect. What does that mean? Well, if we draw out something like this, and we actually draw out two lines, I'm going to draw one this way and one this way. Look at this. I call them my vegetarian lines because they never meet. Get it? Vegetarian, never meet? Okay, bad joke. All right, fine. But these are lines that never meet. But look at these lines. I want to show you something really, really important about them. Look at the slopes of these lines. They are the same. The only difference is this thing, where they cut the y-axis. Okay? What do we call the points that cut the y-axis? We call them intercepts. Yes, and specifically, these are going to be y-intercepts. Makes sense. So look at the second part of this definition. These are lines that have the same slope, but different y-intercepts. They forgot to put the word y in there. Okay? So different y-intercepts, but same slopes. So let's look at the next little slide here. Here we go. Look, it says parallel lines have the same slope but different y-intercepts. So what did I write down here? Look what I wrote down here. This is interesting. Same slope. That means the slope of the first graph is the same as the slope of the second graph. That's what m1 equals m2, because remember, the symbol m means slope. So the slope of your first one is the same as your slope for your second one. Okay? So let's look at this. Okay, this also includes, which is really, really neat, this also includes horizontal lines, okay, which have the same slope of 0, and vertical lines which have that undefined slope. Those are also considered to be parallel. What am I talking about? Wait a second. Let's clarify it right here, right now. Look at this particular one. I've got this beautiful blue line going like this. And if we actually figure out the slope of this and we do rise of 1, 2, the rise of 2, run of 1, we figure out the slope to be 2 over 1 or just plain old 2. And that's one of the reasons why they put M1 is 2 right there. Take a look at this guy right here. And I'm not going to pick the 2 dots that it chose. I'm going to pick a dot right here, and I'm going to find another dot along this line that intersects beautifully. Look at that, right there. Let's figure out the slope of that line based on those 2 points. Check this out. I'm going to go up 1, 2, 3, 4, and over 1, 2. Rise of 4, run of 2. Rise of 4, run of 2 gives me again a slope of 2. With the both slopes being the same, I can comfortably say that those 2 lines are parallel. They're different lines because they intersect at different points. See that? Okay, so looking over here, notice that the slope of these guys are undefined, but this is going here straight up and down. If this slope is undefined and this slope is undefined, they equal each other, which means, yep, those are parallel. And finally, if you think of horizontal lines, which we haven't plotted here, but we've got a horizontal line going here, and we've got another horizontal line going here on our axis, okay, on our XY axis, look what happens. Those are also parallel because they have slopes of 0. You get it? Cool. Okay, so now let's put this to use. Here's a neat example. It says, consider the line segment AC with a slope of 3/4. I want you to tell me another line that has a slope that is parallel to AC. Well, wait a second. Okay, if AC has a slope that is 3/4, give me another line. Let's call it Q and R. What would the slope of this line be? Well, if they're going to be parallel, and that's the symbol for parallel lines, 2 little kind of dashes like that, they have to have the same slope. So the slope of this guy would also be 3/4. Yippee skippy. Question's done. That's how easy it is. That's how nice parallel slopes are. So with that in mind here, I want to go to question number 2. Now I'm not going to give you the slopes. Now I'm going to give you some points. And I'm going to say, is AB parallel to CD? There's the question. Okay, so first things first, I think what would probably be advantageous here for you is to figure out the slope. So let's figure out the slope of AB. So I'm going to call this point 1 and this one point 2, which means this is now x1, y1, x2, y2. Do you see what I'm going to do? I'm going to figure out the slope of this guy. So here we go. Slope of AB equals y2 minus y1, x2 minus x1. Let's go to town. Y2 is minus 2 minus y1 is 7. Check this out. X2 now is minus 5 and x1 is minus a minus 3. Okay, minus 2 minus 7 is minus 9. Minus 5, oh, look at this. Negative, negative makes it a positive. Minus 9, so we've got minus 5 plus 3 is minus 2. I have minus 9 over minus 2, which is just plain old 9 over 2. Now, if that slope matches this guy, they're parallel. Okay, so I guess our next step is to find out what the slope of CD is. Okay, so check this out. I'm going to just clean it up a little bit. Okay, look at this. Point 1 is this guy. Point 2 is this guy. Okay, so that means I can label these guys now as x1, y1 for my new situation and x2, y2 for my new situation using the same formula that I had here. Okay, I now have 7 minus a minus 3 over 1 minus a minus 1. 1 minus a minus 1. And look at this. 7 minus 3 then makes that a plus, makes that 10. 1 minus a minus 1, that makes that a plus, makes 2. So my slope is actually 5. So guess what? These aren't identical at all. Which tells you right away these are not parallel. They are definitely of a different slope. Slope of CD does not equal to the slope of AB. They're not the same line. They're not parallel, and everything's cool. If they were parallel, those two slopes should be equal.